You for your work. So we have the plan to have an appetizer of Manuela's presentation. Lunch will be served at 12:30, and so this session is coming to a close here. Just to say that these questions that you've documented at your tables will return to again this afternoon in our large group circle, large group conversation. So we're building our knowledge together and our questions together, and hope to build on it step by step today and tomorrow. So thank you for your work. I suggest that you also stand up and turn around and shake out the conversation a bit and get ready to clear your mind for Manuela, who's got a brief presentation for us up to lunch.
That's me, yes. And so what I did, I changed to my computer because it was a different version of PowerPoint.
Yeah.
It wasn't working well.
That's good.
Is that okay?
Yeah, no,
so
totally.
just
Let's see if it works.
yeah. And I can just see.
Okay, I'll look for the seat. Okay. And do I need to? I don't want to mess anything up.
You okay? Are you going to do it? Or are you going to do it? Are you going to speak from here or up here? From there. Hello, is this working? Hello, hello. Is this working? Can you hear me? Yeah, there we go. So can we settle down again, please? You can stay where you are. You can sit wherever you want. You don't have to go back to any particular seats. Okay? Can we sit down? Can we settle down, please? And we're going to go on to our next panel, or two speakers, which is on public policy. And the first person that we're going to hear from is Manuela. Wait till I get your right name, Manuela Paseo de Miranda, from the convention, the Office of the Convention on Biodiversity in Montreal. Manuela is the Acting Senior Program Officer of Biosafety and Security at the Convention on Biological Diversity. She's been involved in many of the negotiations, the Cartagena Protocol, I don't know what all, for years on biotechnology, biosafety, and those issues. And we're really looking forward to hearing about what's happening at the international level. Thank you.
Thank you, and you were too fast. I was hoping to have some food before. I'm sorry, no, my apology. But actually, this is not food, this is a vaccine. Actually, no, looking at it again, I think this could be a weapon. This is the problem. We don't know what we're eating. We don't know what's reaching us every day. And this is where we, our small group in Montreal, together with many governments, try to help, is to try to guide governments to take the right choices. to make the right decisions so that the public at large benefit from it. So let me try to introduce a little bit of the work that we do. There is an international agreement called the Convention on Biological Diversity. Can I just get a raise of hands? Who has heard of the convention? Okay, pretty good. So I won't go into great details, but the convention it entered into force in '92. It's a nearly universal agreement. Only the Holy See and the USA are not parties to the convention. Otherwise, all other countries are, so nearly universal. The objectives of the convention are to conserve and is the conservation sustainable use of biodiversity. So it's an environmental agreement. We need to keep that in mind. Our focus is on protecting the environment and using it in a sustainable way. And the third, so one is the conservation, the other one is sustainable use of biodiversity. There is a third objective, which is defend equitable sharing of the benefits arising from the use of genetic resources. We will see that this morphed into a separate protocol. In addition to the convention, so a convention is where countries agree on general rules, measures that will drive the agenda, in this case for the biodiversity, and make improvements for the good of the globe. But it's not a legally binding instrument in the sense that there is no compliance to it. There is no compliance mechanism to see if countries are actually following it or not. Then under the convention, there are two protocols. Protocols, yes, they are legally binding. They have a compliance mechanism, can be soft or harder, depends. Usually in the United Nations, nothing is very hardcore. It's all very soft law. But still, at least in theory, it's a protocol, legally binding, that has a compliance mechanism that can go to countries and say, look, you're in non-compliance. The Cartagena Protocol on Biosafety is specifically focused on biosafety. So it's no longer, we're not talking about biodiversity in general, we are talking about biosafety. So the safety of GMOs. It's a very large agreement also. It entered into force 17 years ago, and it has 171 parties. And the objective is to ensure the safe use. We call it living modified organisms. It's the same thing as a GMO, a genetically modified organism, as long as it's living. So once it's dead, or if it's a product of a GMO, it's no longer within the scope of the protocol. And it also focuses on the import and export between countries. So perhaps the most important thing of the Cartagena Protocol, if I were to single one thing out, would be that countries are mandated to do risk assessments, environmental risk assessments. It's not an option, they are mandated to do risk assessments before they introduce a GMO into the environment for the first time. And that risk assessment has to be on a case-by-case basis, which is very important in this sense because, in particular, the receiving environment. So if something was done in the USA, for example, a corn, a maize, was assessed. Let's use another country that's a party. Let's say it was done in Brazil, an assessment of a particular GM corn was done in Brazil. Mexico cannot just take that assessment and say, okay, we rubber stamp it, it's our assessment now, we endorse it. No, they have to do their risk assessment based on the local conditions, which in the case of Mexico, introduction of corn could lead to quite negative impacts, especially cultural and social, but also to biodiversity, to the loss of genetic diversity. So this is the Cartagena Protocol in a nutshell. If we could look at the next protocol, it's a much younger protocol, only 3 years old. It's related to the third objective of the convention. It's access and benefit sharing of the use of genetic resources. It has already 100 parties, so it's quite the number is growing quite fast. And the objective is defend equitable sharing of benefits arising from the utilization of genetic resources. It also covers traditional knowledge, so it works very closely with indigenous peoples and local communities. The highlight of the ABS protocol, as we call it, the Nagoya Protocol, ABS protocol, is that before accessing a genetic resource, you need a prior informed agreement, prior informed consent, which can then establish the remuneration, a compensation scheme, whatever, but that's the requirement. So a prior informed consent is needed before accessing the genetic resources of a country. So at the United Nations, there's no view that synthetic biology, or I'm still talking about biotechnology. We will move to synthetic biology in a bit. But we call it modern biotechnology just to differentiate from fermentation, for example, and other more traditional techniques. But there's no view that modern biotechnology is good, is inherently good or bad. What there is a great potential by combining modern biotechnology, biosafety, and access and benefit sharing. There's a great potential for benefit for biodiversity, human health, and the fair and equitable sharing of benefits. There is a caveat, though. There is an unknown in the equation. And that unknown are the uncertainties. So does that really equate? If we combine these three things here the best we can with the knowledge that we have, will we achieve that? So that's the biggest challenge that we are faced now, governments are faced now. So it's a bit, it's too bright perhaps the room, but it's fine, I think we can see. We work primarily, so we are there at the center, not that we are more important or anything, just because that's where we work, and we work with national governments. But there is a number of other stakeholders, as we call. We have NGOs, we have international government organizations. We work with Monsanto. We work with Syngenta, too. We work with the indigenous and peoples and local communities. We work with the consumers, civil society, with the biotech companies I mentioned. We work also with religious organizations and the academia. Each player plays a role in it. And that's important in our processes. The voice that we hear are the voice of the governments, what the governments want, but everyone provides input into that. And we are going to talk a little bit about stakeholder engagement. Debbie is going to talk about that. But in a nutshell, if you want to get involved, channel your views through a country. That's the easiest way to get your views into the United Nations processes heard, is to work with countries. Work with NGOs, but also try to work with an organization that's from the federal government or from the national government of your country. That's the shortest way to reach our ears, and so then it's shared by all parties. So here I'm singling out the Cartagena Protocol on Biosafety because that's the closest there is at the international level that could regulate synthetic biology. But before moving to synthetic biology, let's look at what the Cartagena Protocol does in terms of modern biotechnology. So are organisms addressed? Is it within the scope of the Cartagena Protocol? Yes. Products and components, so I'm talking about the non-living stuff, it's not addressed. Import of export, yes. National level, I put no there, but it's very mild, the obligations at the national level. Socioeconomic, cultural, and ethical considerations. I put a tiny faint yes, but it's really a no. And then human health, same thing. There is human health mentioned in the Cartagena Protocol, but in the context of biodiversity. So we are not looking straight into human health. We are looking how human health is affected by changes to biodiversity. So here I'm circling the no's, and those are gaps. Already modern biotechnology. I'm still talking about the traditional, if you wish, modern biotechnology. Sorry for the dichotomy, but that's how people have been classic or traditional modern biotechnologies, how we are referring to GMO 1.0 as opposed to GMO 2.0. That would be synthetic biology. So now, how can these three instruments address, how and can these three instruments address synthetic biology? Now is the big question. We heard from Jim how countries are trying to bypass regulations not countries, but many developers of the technology are trying to bypass the regulations by saying biosafety don't apply, biosafety laws don't apply to the products that we are developing. So that's now the biggest question that we are trying to answer, primarily under the convention, but also under the two other protocols, is to what extent can the legality of these instruments apply to products of synthetic biology. So let's step back again a little bit. The techniques of the classic modern biotechnology are the first two, as defined by the Cartagena Protocol. The in vitro nucleic acid techniques, which is most of the GMOs are produced through these, but pretty much 100%. And there's cell fusion that when the protocol was negotiated, there was potential, but it never really took off. There's very little in terms of commercial products, if any, that were produced through cell fusion. However, synthetic biology now is the question. Is synthetic biology within the scope of the Cartagena Protocol or not? So remember, if it's within the scope, there's a number of rules that are triggered, of obligations to countries. So this is a very, it just touches the surface between the differences between the two. So there's always this debate. Is synthetic biology just a continuation of modern biotechnology, or was there an inflection point? So let's just go through the left here very quickly. Modern biotech, as described in the Cartagena Protocol, was built on the premise that there was a genetic cloning and construct, so typically a promoter, gene, a terminator, so we knew what those different DNA fragments were. It was very slow. It was relatively random, or it was quite random. You transformed an organism, you regenerated hundreds, if not thousands, of organisms to try to find those that had the characteristics that you were looking for. So it was a very tedious work, but also it took very long. And most of the commercial products are mostly plants, crop plants, and microorganisms. Now, if we look at synthetic biology, the techniques, you could think of a continuum. It was perhaps for some things were a natural evolution, if you wish, of the techniques of modern biotechnology. For example, the high throughput DNA sequencing. It was a continuous improvement of the techniques that now allow DNA sequencing. It's very cheap, can be done. You can sequence millions of DNA sequences in a short period of time. But there were also new techniques that were a jump from what we were doing before, or what people were doing before, which is genome editing is one of them, RNAi spraying, epigenetic engineering, gene drive. These are all techniques that they are reality now. They're no longer just hypothetical. They are reality. Some of them even at the commercial level. There's also something else that these techniques all have in common. They're very fast. I'm going to show you a few slides later on this. They're also more deliberate in the sense as opposed to random. They're more precise. I don't like to use the word precise because it gives the idea that something is positive if something is precise. But it's precise in the sense that you know what you transform and you want to transform exactly that. However, if it's not precise in the rest of the genome. So there can be still changes, a lot of changes to the genome that you're not aware of. And that's the problem. People are too focused on the changes that they're looking for, and they don't know what's happening around the rest of the genome, even with genome editing. And also something that's different from the past is that the techniques are now very easily applicable to animals. So we are having a number of animals being developed through genome editing. So let's look at the global area of biotech crops. These are millions of hectares between 1996 and 2014. The blue line here is the millions of hectares. We see continuous and very sharp increase. But what's interesting here, if you see this, I hope you can see a faint yellow line here, and there's the orange line. It started in the developed world. that crops were planted, GM crops were planted. But at some point, that's in the late 2010, around 2010, there was an inversion. Now the area planted with GM crops in the developing world is larger than in the developed world. That raises a number of questions in terms of regulation. We know that to do a risk assessment takes years, a lot of money. How are these countries doing the risk assessment to their conditions? So the short answer is they're not doing it. Or they're doing something that they're submitting to us a document that says that they did a risk assessment, but it's really a document provided by the developers. It's the risk assessment of the developers that they just rub a stamp and say it's their risk assessment. Unfortunately, it's not usually even done to their conditions, or they do an experiment that's just a month long in the local conditions, and they say that it was done there. So another timeline here, if we want to see, in 1978, the first living modified organism, so the first GMO was produced. There was a bacteria. In 96, the first GMO was commercialized. There was a tomato. So almost 20 years from the development of the first GMO to the first one being commercialized. And then in the first decade of the year 2000s, we saw the explosion of GM crops everywhere. The big four were developed: canola, corn, cotton, and soybean. In Canada, nearly 100% of the canola, if not 100%, is now GM. In Brazil, the great majority of soybean, which Brazil is the largest producer of soybean, is GM soybean. So if we are eating, whatever you're eating that's not labeled as organic, if it has soy, and a lot of the products have soy, it is most certainly genetically modified, because they also mix, right? So in 2010, the global area reached 150 million hectares, and towards the end of the decade, the first GM animal was developed. Now, if we look, and then it took a few years for Atlantic salmon to be commercialized. Now, let's look at this side of this figure. In 2012, CRISPR was used as the first time for gene editing, for genome editing as a tool. Then we have a year later, we have the first CRISPR plants. Between 2014 and 2016, the USDA decided not to regulate a CRISPR mushroom, and it's being commercialized, and there has been a clinical trial. And now, 2017, there is CRISPR was used in vivo in rodents, so mice. What I like of this image is that we can see how long it took from here to here, almost 20 years. And for it to become something more widespread as it is now. If you look at the time span between the first development of CRISPR and what we have now, these are 5 years. How can governments deal with that? How can, and it's exploded. This is the difference of synthetic biology. It's the biggest difference of synthetic biology. It's not just necessarily in the techniques, it's in the speed, in the complexity of these organisms. And countries are, in my opinion, my humble opinion, countries are not equipped to evaluating the risks. So at least the international community needs to recognize that and needs to say, whoa, slow down. We need time. We need governments and scientists need time to get together and say, what are the benefits? What are the risks? What can we live with? What are the risks we can live with? Next. So, synthetic biology. There are a few things we know we don't know. There's a lot of things we don't know we don't know. So this is what's being discussed under the convention. Of course, we can only discuss what we know we don't know. Sometimes we discuss what we know we will never know, but so what are the benefits? What are the risks? Are the regulatory frameworks adequate? Are risk assessment methodologies adequate? And I'm talking about for biotech, right? Risk assessment methodologies for biotech. How to share the benefits from digital information genetic resources. Coming back to that. So what are the impacts on indigenous peoples and local communities? So these are questions that we are actively, or countries are actively asking, and we are trying to facilitate the dialogue for those questions to be answered. But there are many others yet to come. So these are the highlights of the last COP is the Conference of the Parties. So it's the meeting of these three instruments, the convention, the two protocols. The countries, they meet every 2 years, and they take a bunch of decisions. They take stock of what happened before, and then they make a number of decisions, and then they usually establish, for example, an expert group to look into something. They call countries to submit information. So there's a whole process, and it's very cyclical because it's every 2 years. We will have another COP next year, but these are the highlights of the one that took place at the end of last year, 2016. So under the convention, the countries, the parties took the decision that synthetic biology can have benefits and negative impacts to biodiversity. It sounds a bit obvious, but sometimes in the United Nations we need to say the obvious in order to move forward. But even to say the obvious can take week-long of meetings, going until like midnight, 2 o'clock in the morning, just to say the obvious. Jim can tell, and he's waving and laughing. Like, it's something that anyone could, I think my 5-year-old child could say that, but it took us almost a week to get there. And then, that frames it in a way that it can be discussed under the convention. Still, there are countries saying, no, you forgot paragraph 2.3b of decision X, and where you did not address that little criterion. There are countries saying, and because they want to stop the conversation. And that, I think, is the worst that can happen, is if we stop the conversation. I'm not saying we should put a moratorium on this or that, but if we stop the conversation, if we stop capacity building, then this is, in my view, it's almost criminal. So there was, they reaffirmed the precautionary approach. So they asked countries to take precaution. I'm coming to some of these, I'm coming to more detail to them. They arrived at an operational definition of synthetic biology. I'm also coming to that, so I won't explain now. But they also said that the existing regulatory framework and the risk assessments provide a good basis. I'll also come to that. And that symbioorganisms are similar to LMOs, or to GMOs under the protocol, but they also asked if there are questions. Again, this here is very important, because if they say that, if the parties agree that they're LMOs, so GMOs, it falls onto those regulations. If there was nothing, there's no regulation. So it's something also that's pretty obvious to many people, but it has huge implications, and there was a lot of controversy whether they were or not. Some countries were saying, no, we don't want to discuss this. That's the one common strategy that we encounter. They don't want to adopt a certain decision, but they also don't want to discuss it. And then what are the gaps? Under the Cartagena Protocol on Biosafety, we've been discussing this for 6 years now. Is whether, 6 or 8 years even, whether risk assessment guidance, or whether guidance on risk assessment of synthetic biology organisms is needed. And those would be voluntary guidance, but even then the countries cannot agree. So one thing is, especially perhaps this group has been more focused on the convention, but it's very important also to focus on the Cartagena Protocol, because it's also dealing with synthetic biology. And the Cartagena Protocol constituency is made of agricultural ministries. So it's a lot harder for something that's more environmental oriented to pass a decision, because it's very difficult. The negotiations at our COPs are completely different than the one from the environmental people. It's really profit driven. So even though there are countries, and we had more than 20 countries asking for guidance to be developed on synthetic biology, how to assess the risks of synthetic biology organisms. But still, a few countries are blocking this decision and stopping the process. And then under the Nagoya Protocol last year, they established a process to look at digital sequence information. I'll come back to that also. So very quickly looking through a couple of these decisions that were taken. So the big question is synthetic biology, is it something old or something new? Jim was nicely explaining the inflection point and so on. The expert group that looked into this, they found a way to actually put the two things together. It's both. If I could have the next one, I think it's just oh no, sorry, my mistake, previous, I thought there was an underline there. Synthetic biology is a further development and a new dimension of modern biotechnology. That allowed the Cartagena Protocol to apply, to fall under the scope of the Cartagena Protocol, but at the same time to say it's a new dimension, we need to look at more closely at some aspects of synthetic biology. That's what I think the strongest thing in this operational definition was those two things being put together, further development and a new dimension. Then the need for precaution was something else that I mentioned. The parties urged parties and invited other governments to take a precautionary approach when addressing threats of significant reduction of loss of biodiversity posed by organisms, components, and products resulting from synthetic biology. And this here was a huge fight. They were, and the fight will continue for sure next year. There was a growing movement of countries who wanted a moratorium on gene drive, or at least a temporary moratorium to put, to give countries some time to actually know what to do, to give scientists the time to be able to evaluate the risks of gene drives. And at the end, at the last hour, there was a very weak agreement among the countries. They didn't want to do the moratorium on gene drives. There were a few countries that refused, and the decision became very weak. And then what it does is says the precautionary approach and has a lot of text in between and references to previous decisions can also apply to some living modified organisms containing gene drives. So very weak. And I think that's one of the things I was talking on our discussion table there. If there is a message to take home, that could probably be the strongest one, is that countries need time to evaluate gene drives. It's something that exists already. It's not sci-fi. It exists. It's ready to be, in some cases, it's ready to be deployed, but it can have very serious and irreversible damage. So, going back to risk assessment of LMOs, the countries agreed that the current risk assessment methodologies provide a good basis. And if you see towards the end, the underlying text may need to be updated and adapted for current and future developments and applications of synthetic biology. So this is where the discussion under the Cartagena Protocol come. It empowers the countries that have been trying for 8 years to have those guidelines developed. They simply don't know how to assess, especially developing countries. They have no idea how to assess the risks of organisms developed through synthetic biology. And they're begging for an independent set of guidelines to do that. So digital sequence information is something that's, it's almost like a byproduct of synthetic biology, is the exchange of massive amounts of information on DNA, RNA, and protein sequences that are being exchanged online. And comes the question, who has the right to claim the benefits arising from that information being exchanged? Let's say that it's easy if you think of a person going to another country and picking up a certain plant to develop a pharmaceutical component. You can trace that back and say, no, the originating country should also have some of the benefits. It's already difficult from a legal perspective, but at least the logic behind it is easier. But what happens to the information on something, which is all that they need now? With the information, the current techniques, you can synthesize. You don't actually need to travel to a certain country and pick up that organism and physically bring it to your lab, you can synthesize the relevant DNA from that information that's online. So what countries requested, and again, this was a very difficult discussion, excuse me, was that they set up a process, an expert group, to examine any potential implications of the use of digital sequence information on genetic resources for the conservation sustainable use of biodiversity and the equitable sharing of benefits arising from the utilization of genetic resources. So again, it's just setting up a process. Some countries were expecting to say the use of digital sequence information is a matter for the Nagoya Protocol to look at, so it triggers obligations, but no, that was not possible. They just set up a process to see what are the implications. So again, weak in the sense that this will take longer. Countries were expecting to take home something that they could claim, but that's not the case. So now looking forward, and looking ahead, we have the next COP next year. It's towards the end of the year. And these are some things that related to synthetic biology that may happen. There may be some organisms developed through synthetic biology that will be deemed to be not LMOs. And so the question is, who will regulate them? If there is no international agreement, how will that, especially countries that have no legal framework at all? I mean, our aim is not to help Europe because, with this, because Europe has very robust regulatory system. Even Canada and the US, we may not agree how the regulatory system works, but they also have a regulatory system. But most of the developing countries don't have a regulatory system at all. So they rely on whatever is at the international level as their baseline, as their basis to implement. And why it's so important, the Cartagena Protocol, it empowers a country to say no to importing a certain organism without taking the risk of going into a trade dispute. So a country can say, no, due to, I will invoke the precautionary principle because of uncertainties, and I do not want to import your corn, your soy, whatever it is, into my country. If the Cartagena Protocol did not exist, that country could not do that. So this is the biggest power of the Cartagena Protocol, is to empower countries to do that, to choose. Excuse me. There may be a call for further precaution on gene drive. Some people are mobilizing their like-minded constituencies to go for a full moratorium on gene drive. I think we will have long hours discussing that in Egypt next year. Then there are some technical issues, such as the need for tools to detect and monitor the organisms and products of synthetic biology, guidance on risk assessment, digital sequence information. Oh, thank you. Thank you so much. So there will be a decision on digital sequence information. I don't think that the answer will be so clear or not, whether it's in or out of ABS. It will probably be, this will probably take years, and it will be very obscure. Access and benefit sharing, I'm sorry. So it's the Nagoya Protocol, okay? And then there are future processes under the CBD, so the convention, under the Cartagena Protocol and the Nagoya Protocol, and what's the role of other stakeholders? This is a question for you, and how you can contribute to that. Now, I'm coming close to the end. I would just like to leave a thought worth sharing. And this was posted by a representative of an indigenous community in one of our online discussions. I'll give you a couple of seconds to read. So if synthetic biology is going to change our lives here, we cannot even fathom how they're going to change the life of indigenous peoples. They are so connected to nature as they know it. That's the different types of relationships. It's how they have every single, even a rock has a place, has its place. So I think we need to take really a moment and think of what people are doing. Next one, please. So, and this is the question that we all need to know is, and our governments need to answer this question, is whether the benefits outweigh the risks. In many cases, I hope that the answer will be yes, but it's a serious question that I think we have to demand our governments to look at. Thank you.
Thank you, Manuela. We're going on to Deborah Scott now, who's going to talk to us a little bit about governance and policy. Deborah is a research fellow at the University of Edinburgh on governance of emerging science and technology, sustainable synthetic biology, science policy, knowledge policy, and international law. She's taught outdoor environmental education and practiced international law, analyzed trade policies, a member of the Engineering Life Project, which is a project of the University of Edinburgh. So we welcome Deborah, and I've got lots of questions, but I'm sure we all have. So let's see if this is adding to our knowledge, or at least pointing out the bad guys in this picture.
All right, good morning. This has been a really rich and full morning so far. So what I'm going to do is sort of step back a little bit and take us all through a brief walk past some big picture questions with a few examples along the way, almost all of which have already been brought up this morning. So this is going to be a lot of what you'll have heard the first time round, but helping us come back and maybe put that in some bigger perspective around questions like, what are we governing for? How do we govern biotechnology? And what are these key questions being raised in relation to synthetic biology about the effectiveness and sufficiency of our regulatory frameworks? And where are these questions being raised, right? In which forums, and who gets to be a part of these discussions? So why do we govern biotechnology? And the most basic answer is to ensure that biotechnology and its products do not present unacceptable risks of harm to the environment or human health. But we can complicate that a bit. We can look at the broader complex of policies and mechanisms that influence actions and outcomes. So not just the regulations, but governance more broadly. And when we look at governance, we can ask, what types of research are our state governments funding? Are there funds to produce research around environmental impacts, for example? What kinds of innovation are being nurtured through tax schemes or discouraged through the complexity and cost of oversight processes? How will the distribution of an innovation be shaped by the political economy into which it is introduced? And is it the role of the government to care about that political economy? So does synthetic biology, is there anything different about that? Does it change why we're governing biotechnology? And again, the most basic answer is no. New tools and products may challenge our current frameworks, which I'll talk about some, but we're still governing biotechnology to prevent harm to the environment and human health. But again, if we step back and ask what we're governing for more broadly, synthetic biology gets drawn into all kinds of governmental goals, right? So just one example, many governments right now in the past few years are focused on growing what they call the bioeconomy, which is this economic paradigm shift towards economies in which a more significant share comes from either biotechnology or industries that are based on the use of biological resources. And synthetic biology is seen as key to especially this biotechnology-led bioeconomy because it's going to transform all these industrial processes. And this then raises all these questions. I mean, just one being, where will the biomass to fuel the bioeconomy come from? How will it be produced? These are questions that involve values and political choices, and that's just one example of what we're governing synthetic biology for, in part. So how do we govern synthetic biology? Well, as Manuela described, the Cartagena Protocol is a key international agreement, really sort of the key international agreement governing LMOs. But there are a lot of international agreements that relate to genetic resources and therefore potentially to synthetic biology. I will not be going through all of these, good news. Also, she said, the majority of these are establishing rules and guidelines for what then sort of national regulations and policies or guidelines are going to include. Looking at that national level, rather than trying to sort of systematically lay out the labyrinth of international treaties and national regulatory landscapes, I'm going to focus on what are some sort of open questions of the moment of how we govern. So the main regulatory tools when it comes to genetically modified organisms and genetic engineering have been risk assessment and risk management. So risk assessment is meant to identify potential harms, generally to human health or the environment, and they review potential pathways to harm and determine the probability of such harm, et cetera. And then risk management is meant to determine how best to mitigate those risks and how to manage them. So there's a question of what triggers these risk assessment and risk management processes. And since the 1980s, there have been different approaches to overseeing GMO safety, to determining what that trigger will be. So in Europe, the European Commission asks whether genetic material has been altered in a way that doesn't occur naturally by mating or natural recombination. And so it's looking at the process by which GMOs are made and then identifying them, and if identified, they need to go through the risk analysis process. In the US, regulatory oversight just depends on the final product and its intended use. And it's a convoluted thing, but is it meant to be a pesticide? Is it meant to be a plant pest, a toxic substance, and so on? Those are all regulated by relevant laws. There's no sort of GMO law in the US. As Jim said, sort of GMO 1.0, much of the genetic engineering was accomplished using an agrobacterium, which counted as a plant pest, and therefore was regulated under the plant pest regulations. And in Canada, we have a different trigger again yet, and that is novelty. Is it a plant with a novel trait? Is it a novel food? The production method doesn't matter. So you can genetically engineer, you can traditionally breed, you can do mutagenesis. It gets special risk analysis if it's novel. So we've already got these different approaches. And now with this 2.0, we've got this new suite of what are described as new breeding techniques that potentially challenge these different regulatory definitions. And just one example of that is gene editing and the CRISPR mushroom that that Manuela mentioned. So in this, there's no transgenic material was added, but some of the base pairs of the genome were deleted. And as a result, this mushroom, it prevents browning. Now, the US has decided that as far as the USDA is concerned, it has deregulated it. It doesn't need to go through a specific risk analysis. And according to a 2016 article in Nature, the USDA, as of last year, had deregulated about 20 different genetically engineered plants under this kind of logic. Over in Europe, we've been waiting for over 2 years for legal advice on where such organisms will fall. And no one knows what they're going to decide, right? Because some are arguing, well, we care about process, right? But gene editing, it's more precise. It's more controlled than conventional breeding. And anyways, the genetic changes are going to be indistinguishable from what could happen naturally. Whereas others question those claims of precision and control and what that will mean. So this is an open question of what will happen. So there's what triggers risk assessment and risk management, but there's also the question, as Manuela was saying, is are these existing risk assessment and risk management frameworks adequate in light of the new challenges of synthetic biology? And the Cartagena Protocol has represented a fairly stable sort of majority international consensus on what risk analysis processes are and should be, but that consensus is sort of coming under question. And the most pressing example of this is gene drives, as Manuela said. And it just, there's a number of different questions that get raised by this. So there's a Dutch policy paper last year said, you know what, even doing contained research on gene drives the risk assessments for that aren't adequate. They don't specifically address the potential spread of an engineered trait into the environment. And therefore, the Dutch government changed its GMO decree to specify that gene drive research has to be assigned to the highest containment level. But most governments haven't taken that step, right? And most are interested in contained research. There's the question, and this doesn't get brought up all the time, but there's concern around unintended production of gene drives by using this CRISPR-Cas9 technology, and the concern is that the risk analysis processes at university levels, at institutional levels, won't necessarily catch that. And so some biosafety professionals suggest that any researcher who's using CRISPR should have to go through a series of questions that if the answer is, whoops, might accidentally make a gene drive, that gets flagged. But again, that's just a suggestion. That's not on the rule book. And finally, that question of gene drives and deliberate environmental release. So at the moment, I would say there's general agreement that right now there's insufficient evidence to support environmental release. But for some, that is literally only because it hasn't gone through risk assessment processes yet. And they say that the risk assessment and risk analysis processes on the books should be adequate. But there are so many questions that are still hanging out there. Just to highlight one, Manuela was saying that one of the powers of the Cartagena Protocol is that a country can say no. Well, in light of the potential global impact and reach of gene drives, can a country say no if it's released in any one country? So much. We'll keep moving. We're near lunch. And that's around whether risk assessment is adequate, whether it's triggered. But we can look beyond impacts to the environment and human health, and there are governance questions about whether and how to address these. And just to run through, just to highlight some of them. So what is being assessed? Is environment and human health enough, or should we consider socioeconomic impacts, cultural impacts, ethical impacts? And it's interesting in Europe, there's a 2015 directive that member states are allowed to restrict GMO cultivation on the basis of socioeconomic impacts or environment and agriculture policy objectives. So it recognizes that there can be a broader suite of interests that influences the choices you make. There's also questions around the political economy of scientific research and commercialization, and the Nagoya Protocol and access and benefit sharing gets at that. There's questions about intellectual property rights. For some of the founders of SynBio, definitely Drew Endy, the goal of open, accessible scientific tools was one of sort of the key characteristics of this new field. And so there are questions around, is that vision of openness, has that dropping out of the field as it sort of aligns with industrial biotechnology? But there are projects, there are synthetic biology projects like Open Plant in the UK that are specifically aimed at diversifying the agricultural industry, of supporting sort of the global sharing of open technologies for plant synthetic biology in order to sort of, as they see it, getting the tools of synthetic biology, of plant biotechnology, out from under those three big agrochemical businesses. But this raises a lot of questions, and just one of them is, how does that vision of openness align with the vision of access and benefit sharing? And finally, biosecurity concerns. So we've been really talking about a lot of biosafety stuff this morning, which deals with unintended harms. And biosecurity focuses on attempts to use biotechnology to intentionally cause harm. And that sort of dual use research of concern is the term that's often used. Dual use because it's research that can, say, help us better understand pathogenicity, but also can be used to harm. And if you like, we can talk more about biosecurity at lunch, or at various points if we want to get into that more. But I want to spend the last few minutes around who is getting to make the decision making around this, and who gets to be a part of it. So almost all of the rules and regulations for biotechnology are either made at the national level, or they're taken from the international level, but they're promulgated there. And at the national level, there are consultations, and it is absolutely worthwhile participating in those. But if your government is soliciting your opinion, it's probably to understand if there's public acceptance. Yeah. The goals of and mechanisms for governing are generally not up for debate. You need JD's organization to go to court to challenge that, or you need Jim's organization to engage in a campaign to challenge those sorts of things. But there are also international forums. And, they may only rarely lead to legally binding rules, but they can pressure national governments to move towards emerging international norms. And those are spaces where there can be room to challenge not just how we govern, but why we govern. And there can be more space to find government delegations that align with, say, your vision, right? And that you can then work with them. If your country, at that national level, you've just been sort of batting up against these sort of intractable, incompatible visions. And I'm just going to sadly nod to some spaces where there's active debate happening right now at the international level and around issues around synthetic biology. And if you can go next, that's just highlighting sort of, in my experience, some of the spaces that are where there's more room for stakeholders, for faith groups, for civil society organization, where they're welcomed and they're consulted and viewed. This last one around shaping responsible research and innovation, these are two spaces that have really, that are under the UN and that have worked hard to welcome and draw upon a really broad range of stakeholders. And as far as I'm aware, they haven't explicitly addressed synthetic biology. But the Committee on Food Security could be informing how synthetic biologists understand food security, what responsible agriculture and food system, what those key principles should be. And therefore, how synthetic biology projects could fit into that. And I think both of these could be used to explore some of these pressing questions around how do we assess. And finally, sort of who gets to be involved and why. The most cynical reason to involve the general public is to help guide us towards acceptance, to educate us so that we will not reject something when it finally is commercialized. And that kind of public engagement is happening, yeah. But there's bad news for them. There's plenty of research showing that more science education does not lead to greater acceptance. So what are other reasons for involving stakeholders and individuals beyond sort of the narrow technical experts? So first, these techniques and these organisms that we've talked about, these are entangled inextricably in socio-ecological, legal, political, ethical, community dimensions. And decision-making needs expertise in all these areas. And here I think the CBD has really have some great examples of drawing on a broad range of expertise. So it's got this online forum on synthetic biology that you have to be a certified expert to participate in, but the range of expertise in that space goes from synthetic biologists to lawyers to faith groups to indigenous peoples representatives to social scientists. And I think that this really relates to what Mark was saying yesterday about sort of the four-directional knowledge and recognizing that sort of the scientific and technical knowledge is just one slice of what we need to make the decisions that are facing us. Social scientists such as Brian Wynn and Andy Sterling have long argued that risk assessment is a powerful and great tool, and we use it for too much. That it is too narrow a tool to deal with certain kinds of uncertainties, especially the areas of ignorance where we don't know what we don't know. And they argue that in such instances, such situations, this calls on drawing on a greater range of knowledges, on actively exploring alternatives, on prioritizing actions that are reversible, and engaging with communities just like this one is part of that, I think. And finally, when you don't provide space for serious debate over what are essentially political visions for the role of biotechnology and our future and what we govern for and our food systems, when you confine those discussions to technical spheres, those disagreements, those debates, they don't go away. They fester. They overflow. And so I think that is a reason, again, that governments and that these different bodies should be drawing on folks like us. So this has been a brisk pre-lunch walk. I hope it's been helpful, at the very least not harmful. While we don't have time for discussion now, if you have questions, I'm happy to point you to resources, and hopefully this can set up our continued discussion throughout the next day and a half. Thanks.
Thank you, Deborah. Thank you very much, Deborah. And I am sorry about we are going to get into discussion afternoon, but we're getting so much information. And I know I've got questions about our government and about, what we can do, and we'll come into that this afternoon, I'm sure. There's lunch now. We're coming back at 2:30, and there will be a half-hour conversation with Drew. And we'll figure out what Drew's going to say when Drew gets up to say it, I guess. He's going to be talking about synthetic biology, isn't it, the beginning? And then after that, we're going to go into a circle, and Peter's going to take us through a conversation, stories and a conversation.
Yeah. So just a quick thing on that. Since we're going into a circle, that means pushing the tables to the sides and creating a circle of chairs in the middle. So maybe pick up your things and arrange them somewhere else in the room so that we can do that during the lunchtime. Yeah, I think we can actually even do Drew in the circle. Yeah.
Yes.
Can I just say something then? Very quick.
You need a mic.
I'm unfortunately leaving right after lunch. It's just if someone wants to talk to me or has any questions, please come to me at lunchtime. Sorry, and to interrupt. I was afraid you would end and finish and everyone would stand up.
That's right. And please sign up for the lunch, whether you want to go to the restaurant or you're staying here, or if you're doing something other, you don't need to sign up. Dinner. Sorry, lunch is here. Lunch is in the dining room. So please have lunch. You can either eat in the dining room, you can bring your stuff back here, you can eat in the sitting room. You've got the whole ground floor of the house too. But thank you very much. Thank you.